Today we're going to be looking at rational expressions. So the word rational in math means fraction. So you can think about rational as being fractional. So a fraction exponent is just basically going to have a numerator and a denominator, and it's going to have a polynomial on the top and a polynomial on the bottom. So what we'll be doing today is we'll simplify, we'll add and subtract those rational expressions, and we will multiply and divide those rational expressions. So first, let's talk about how do you simplify rational expressions. So remember that rational expressions are going to be a fraction. So the first thing that you're going to do is you're going to factor the top and the bottom. So you're going to factor the numerator and the denominator of your fraction. And then once you factor them, you're going to cross out like factors. And the reason that we're crossing them out is because what we're really doing, if they're on the top and the bottom, is we're really dividing out those like factors. So on example 1, if we want to simplify the rational expression and find the excluded values, the first thing that we would do is we would say, okay, I have a 6x on top and a 15 on the bottom, so I can't factor the top or the bottom, but I can say 6 and 15 have 3 in common, so I could divide the top and the bottom both by 3, and if I divide the top by 3, that would give me 2x, and if I divide the bottom by 3, that would give me 5. So I would have 2x over 5. Now when we talk about excluded values, that's something that's important with our rational expressions, because we have a fraction. Remember that we can never divide by 0. So remember that fractions can't divide by 0. So remember that basically means we can't have 0 on the bottom of a fraction. So when we talk about excluded values, these are going to be values that make the bottom equal 0. And so I don't have to worry about that for example 1, because I don't have to worry about this 15 ever becoming a 0, because there's no variable there. On example 1b though, I am going to have to worry about some excluded values because I have this variable here in the bottom. So first let's just simplify, and then we'll worry about what our excluded value would be. So I've got 15x squared over 25x cubed. So I notice that I've got x's on the top and on the bottom, and I notice that my coefficients are 15 and 25, which are both divisible by 5. So I could say 15 divided by 5 would give me 3, so I'd have 3x squared on the top, and then on the bottom 25x cubed, I would say 25 I can divide by 5, and that would give me 5. So I'd have 3x squared over 5x cubed. But I've got those x's still that I could simplify out or divide out. And so because I've got 2 on the top but 3 on the bottom, I would subtract those exponents and put my answer with the part that has the most x's. So the bottom has the most x's, so I would say my coefficients will stay, but my x squared that's on top would come to the bottom, which would make it subtract, and I would say x to the third minus 2 would give me x to the first. So you could also think about it like this. If there was x squared, that'd be x, and on the bottom if there's x cubed, that'd be x, and x, and these would just cancel, leaving me with that 1x on the bottom. Now, remember, we want to make sure that our bottom of our fraction doesn't equal 0. So that means if I think about that, the only way that the bottom of this fraction could equal 0 is if this x was a 0. No other number would I plug in for x would give me 0 on the bottom of that fraction, only if I plugged in a 0 for x. So that means that my excluded value is going to be 0. So what that means is x cannot equal 0. Alright, on example 1c, I've got negative 8x over 24x squared. So again, I'm going to worry about my coefficients, and I'm going to see what I could divide negative 8 and 24 both by. So negative 8 and 24 are both divisible by 8. So if I divide 8 by 8, it's going to give me 1, but that's a negative, so I'm going to make it a negative 1. So it would be negative 1x because that x is already there. And then the 24 on the bottom, when I divide 24 by 8, gives me 3. So I'd have 3, and then I'd have x squared. All right, I still have to deal with my x's. So I've got 1x on the top and 2 x's on the bottom, which is going to just give me 1x on the bottom. So I'm going to have negative 1 over 3x. So just like on the last one, we've got to figure out what would make the bottom of that fraction 0. And so the only thing I could plug in for x that would give me 0 on the bottom would be if I plugged in a 0 for x. And so that means that my excluded value would be 0. So x cannot equal 0. This means that x can literally be any other number. The only number it can't be is 0. So example 2 gets a little bit more difficult. So now we're going to have multiple pieces in either the top or the bottom of our fraction. But remember, we're going to just factor the top and the bottom, and then we're going to cross out things that they have in common. So if I factor the top, 4x plus 12, the only way I can factor that, because it's got 2 terms and the highest exponent is a 1, would be if I took out a GCF. So if I think about 4x and 12, 4x and 12 are going to share 4. And so if I took out a 4, that would make x plus 3 inside a set of parentheses. Because remember, I want to take this 4, distribute it back out, and I should be able to get 4x plus 12. So if I say 4 times x, that's 4x, and 4 times 3 gives me 12. On the bottom, I can't factor 8, so I just leave it as 8. Now at this point, I can't do anything else with what I have except for the 4 and the 8. 4, when I divide 4 by 8, is going to give me 1/2. So that's going to make this 1 times x plus 3 over 8. Now I could also just see that written as x plus 3 over 8. Now on this one, I don't have to worry about any excluded values because no number that I plug in for x is ever going to affect the bottom of that fraction. So the bottom of that fraction is always going to stay just a number. And actually, this is not 8 on the bottom. This should actually be 2, sorry. So let's go back and talk about that one again. So if I divide out 4 over 8, that's going to turn into 1 over 2. So this should really be x plus 3 over 2. But like I said before, no value that I plug in for x is ever going to affect that 2 on the bottom. Alright, for B, I've got 7x plus 42 on the top and x plus 6 on the bottom. So I'm going to start by factoring the top. The only way I can factor the top is by taking out a GCF, which would be 7. So that would be 7 times x plus 6. And on the bottom, I would have x plus 6. So remember, my second step, once I factor, is to cross out anything that they have in common. And so they have in common x plus 6, so I cancel that out. That makes my answer just 7. Now, I do have an excluded value on this one because if I look back at the way my fraction was originally written, I had x plus 6 on the bottom. So I could have plugged in a number here for x that would have given me 0 eventually on the bottom. Now, the way that I deal with something like this is I'm going to take the bottom and I'm going to set it not equal to 0. And then I'm going to solve and find out what x cannot equal. So to do that, I would subtract 6 on both sides here. And that's going to tell me that my x cannot equal negative 6. On example 3, I need to be able to factor the top and the bottom. So to factor the top, I would see that I had 2 terms, and the highest exponent is going to be x to the first. And so I need to find a GCF. So I'm going to take out a 2 because 2 is the biggest number that will go into 2x and into 6. And when I factor the top, that's going to give me 2 times x plus 3. Now to factor the bottom, I notice that I've got two terms, but I've got an x to the second. So if I've got an x to the second, I can probably use the star method. To do the star method for this one, my a would be 1, my b would be 0 though, because notice I don't have an x term, and my c would be -9. So when I go to do my star, I would end up with 1x on each side. I'd end up with -9 at the top and 0 at the bottom. Now to get -9, to multiply to get -9, but to add to get 0, I'd need a 3 and a -3, which means that when I factor the bottom of that, x squared minus 9, it's going to turn into x plus 3 times x minus 3. Now remember, once I factor, I'm going to see if I have anything that crosses out. And so to cross out, it has to be the same. And so I have x plus 3 on the top and x plus 3 on the bottom, which means that those are going to cancel. That's going to give me 2 over x minus 3. Remember, we still want to get our excluded values though. And so to get our excluded values, we're going to use the factored form. So we're going to use kind of like this middle step here. And so remember, we're only looking at the denominator. So to find out what our excluded values would be, we'll take the factors on the bottom, set them not equal to 0. And then we're going to solve for x. So we're going to subtract 3 on both sides here. Those will cancel and we'll get x does not equal -3. Here we're going to add 3 to both sides, and we're going to get x does not equal +3. So my answer is 2 over x minus 3, where x cannot equal -3 and x cannot equal +3. For example 3b, I've got to factor the top and factor the bottom. So I'm going to have to do the star method for both of these. So I'm going to start with x squared plus 6x plus 5. My a would be 1, my b would be 6, and my c would be 5. So I would do my star, and I would say I need to multiply to get 5, but add to get 6. So to multiply to get 5, but add to get 6, I would do 1 and 5. So when I factor the top, I'd have x plus 1 times x plus 5. On the bottom, I would say x squared plus 2x minus 15. So my a would be 1, my b would be 2, and my c would be -15. So I would be looking for two numbers that multiply together to give me -15, but add to give me 2. So that would be 3 and 5, where 5 is positive and 3 is negative. So that's going to give me x minus 3 times x plus 5. And so then I'm going to cancel out the things that they share on the top and the bottom. So that would be the x plus 5, which is going to give me x plus 1 over x minus 3. Remember, I need to get my excluded values by using my factored form of the bottom. So to get my excluded values, I'm going to take those factors and set them not equal to 0. So I would add 3 to both sides here and get x cannot equal 3. Subtract 5 from both sides here and get that x cannot equal -5. So my answer would be x plus 1 over x minus 3, where x does not equal 3 and x does not equal -5. On example 4, I need to factor the top and the bottom, so I'm going to start with x squared plus 3x minus 4, and I'm going to do the star method. So my a would be 1, my b would be 3, and my c would be -4. So I'll be looking for two numbers that will multiply together to give me -4, but add to give me +3. So a +1 or +4 and a -1 will do that. So my top factors will be x minus 1 times x plus 4. On the bottom, I've got, let's rearrange the bottom a little bit. So let's make it negative x squared plus 1. So now let's factor the bottom. So to factor the bottom, I can use the star method again, where my a is negative 1, my b is 0, and my c is positive 1. So I would find two numbers that would multiply together to give me 1 but add to give me 0. So that would be positive 1 and negative 1. This would cancel and become x over 1 because my negatives would cancel. And so that's going to give me x minus 1 times x plus 4 over negative x plus 1 times x plus 1. Now notice that this one's kind of similar. So if I wanted to, I could take out a negative. If I took that negative out, it would make it x plus 1 times x minus 1. And so now I've got some things that will cancel, which will give me my final answer of negative x plus 4 over x plus 1. So all I did was take that negative that was on the bottom and I moved it up to the top. And that's just so it doesn't get lost. So remember, I also want to get my excluded values. So to get my excluded values, I take my factored forms and set them not equal to 0, so the factored forms of the denominator. I would subtract 1 here on both sides and get negative x does not equal negative 1. I'd need to divide both by negative 1, so I'd get that x cannot equal 1. And here I'd subtract 1 from both sides and get x cannot equal negative 1. And for 4b, I would need to do something similar. So I'm going to start with x squared plus 5x plus 6. Do the star method by saying a is 1, b is 5, c is 6. So I need to find two numbers that are going to multiply together to give me 6, but add to give me 5. So that would be 2 and 3. So when I factor the top, it's going to be x plus 2 times x plus 3. And then I need to factor the bottom. So when I look at the bottom, I can see that I have essentially negative 3x squared plus 12. So my a would be negative 3, my b would be 0, and my c would be 12. I would need to find two numbers that would multiply together to give me negative 36. Remember, this comes from a times c, a being negative 3 and c being 12. And the bottom has to add to give me 0. So to do that, I would need 6 and negative 6. Both of these sides, they were going to be divisible by 3. So that's going to give me negative x over 2 and x over 2. But I need to make sure that I keep that 3 out front. So this is going to be 3 times negative x plus 2 and positive x plus 2. So my x plus 2's will cancel, and that will give me x plus 3 over 3 times negative x plus 2. I need to get my excluded values by taking the bottom of my fraction and setting each of the factors not equal to 0. I don't have to worry about the 3 because it doesn't have any x's, but I do need to worry about the negative x plus 2 and the x plus 2. And so I would subtract 2 from both sides and get negative x does not equal negative 2. Divide both sides by negative 1, and x does not equal positive 2. Subtract 2 from both sides here and get x does not equal negative 2. So my answer would be x plus 3 over 3 times negative x plus 2, where x does not equal 2 and x does not equal negative 2. To multiply rational expressions, the first thing that you're going to do, just like before, is you're going to try to factor. So you're going to factor if possible. The next thing that you're going to do is you're going to multiply straight across. So when I say multiply straight across, I mean numerator straight across and denominator straight across. And the last thing that you're going to do is you're just going to simplify, just like we did on the last examples. So on number 5, I've got 12x squared over 7 times 5 over 4x to the 4th. So I would try to simplify if I could, but there's nothing I can simplify in the first fraction or the second, so I'm just going to multiply straight across. Now remember, to multiply straight across, I'm going to say 12 times 5, which is 60. And then this has an x squared, so it's going to be 60x squared. Then on the bottom, I would have 7 times 4, so 28, x to the 4th. And then I would need to simplify. And so to simplify, I would say 60 over 28. And so 60 and 28 can both be divisible by 4. So if I say 60 divided by 4, it's 15. And 28 divided by 4 is 7. So 15 over 7. Then I have to worry about my x's. So 2 x's on the top and 4 x's on the bottom means I'm going to have 2 x's left over in the bottom. For this one, my excluded value would be x cannot equal 0. On example 6, x squared plus 2x minus 3 over 3x plus 9 times x plus 5 over x squared minus 3x plus 2. I'm going to need to factor the top and the bottom if possible. So I'm going to start with x squared plus 2x minus 3, and I'm going to do the star method. So a is 1, b is 2, and c is negative 3. So I would be trying to multiply together to get negative 3, but add to get positive 2. So that would be a 1 and a 3, where 1 is negative. So the top of that fraction is going to look like x minus 1 times x plus 3. On the bottom, I would have 3 times x plus 3. I can simplify this fraction because I can cross out these x plus 3's, and that makes my life a little easier. On the second fraction, I've got x plus 5 on the top, and I need to factor the bottom. So I'm going to do x squared minus 3x plus 2. So my a is 1, my b is negative 3, and my c is 2. So this is going to give me 2 and negative 3, so I need to multiply together to get 2, but add to get negative 3. So negative 2 and negative 1 will do that. So that will make x minus 2 times x minus 1. Now notice that my x minus 1's are on the top and the bottom, just on different sides. But those will still cancel out. So this will go away and this will go away. This has already gone away. So that's going to leave me with x plus 5 on the top. That's the only thing that's left. And on the bottom, I would have 3 times x minus 2. Now for this one, my excluded values are a little tricky. Anything that was ever in the bottom, you've got to find what would be excluded because of that. So I had x plus 3 does not equal 0. so my x could not equal negative 3. I had an x minus 2, which can't equal 0. So my x cannot equal positive 2, and I had an x minus 1 cannot equal 0. So my x could not equal positive 1. So I can plug in any number that I want to for x except for negative 3, positive 1, and positive 2. On example 7, I'm going to factor the top and the bottom of my fractions. So I'm going to start with x squared minus 9x plus 20. So my a would be 1, my b would be negative 9, and my c would be 20. So I would want to multiply together to get 20, but add to get negative 9. So that would be negative 4 and negative 5. So the top of that fraction would factor to x minus 4 times x minus 5. The bottom of that fraction is x squared minus 25. So my a is 1, my b is 0, and my c is negative 25. So I would need to multiply to get negative 25, but add to get 0. And to do that, that would be 5 and negative 5. My x minus 5s will cancel because they're on the top and the bottom. And I'm multiplying by x plus 5. That x plus 5 is over 1. But I notice that I've got x plus 5 on the top and x plus 5 on the bottom here, so those will also cancel out, which will give me a final answer of x minus 4. I still need to do my excluded values, and remember anything that was ever in the bottom is considered what I have to consider for my excluded values. So I'm going to say x plus 5 does not equal 0, so subtract 5 from both sides and get x does not equal negative 5. And x minus 5 does not equal 0, so add 5 to both sides, and x cannot equal positive 5. To divide, the first step I'm going to do is I'm going to factor the top and the bottom, if possible. Then I'm going to keep the first fraction exactly as it is. For the third step, I'm going to flip the second fraction. My fourth step is I'm going to multiply this time instead of dividing. And my fifth step is going to be to simplify. So I want you to keep in mind that I'm dividing. But in order to divide two fractions, I have to keep the first fraction, take the second fraction, flip it, and multiply. So you may remember this back from middle school when you were dealing with just regular fractions. So if I had had something like 1 over 2 divided by 2 over 3, that would turn into 1 over 2 times 3 over 2. So you may remember that back from a long time ago. So you're going to do the same thing, this time though just with polynomials. So my first step on number 8 is to see if I can factor. So I can't factor my first fraction, and I can't factor my second fraction, so I'm going to keep it as it is. So my second step is to keep my first fraction, but to take my second fraction and flip it, and now to multiply. And so to multiply, I'm going to say 16 times 20. So when I do 16 times 20, it gives me 320. And I've got 2 x's here and 2 x's there, so that makes x to the 4th. On the bottom, I'd have 25x squared times 8. 25 times 8 would give me 200. and I'd have x squared. $320 and 200 are both divisible by 40. And so if I did 320 divided by 40, it would give me 8. So I'd have 8x to the fourth. And on the bottom, if I had 200 and I divided it by 40, it would give me 5. X to the second on the bottom. This is actually supposed to be x to the third. Go back and fix this. So this should be x to the third here and here. And so if I've got 4 x's on the top and 3 x's on the bottom, because the top has more x's, I would say 4 minus 3 because I'm dividing, and that's going to give me x to the first. So I'm going to have 8 over 5 x to the first on the top. My excluded value would be that x cannot equal 0 because the bottom of my fraction, before I reduced it, had x to the third in it. And so the only value that I would plug in there that would give me a 0 on the bottom of that fraction would be if I plugged in a 0. On example 9, I need to factor. So I'm going to go ahead and start with x squared minus x minus 2. So a is 1, b is negative 1, and c is negative 2. So I would be trying to multiply to get negative 2, but add to get negative 1. So that would be 1 and 2, where 2 is negative. So the top of my fraction is going to turn into x plus 1 times x minus 2. The bottom of that fraction I can take out my greatest common factor, which is 2x, and that's going to leave me with x plus 1. Remember, I should be able to factor that back out and get 2x squared plus 2x. So I'm going to keep my first fraction. Actually, I can cross out these x plus 1s, which will make my life a little easier. And then I'm going to take my second fraction and I'm going to flip it. But let's go ahead and simplify. So let's take this 5x minus 35 and take out a 5. So that would be 5 times x minus 7. And let's take the bottom, the new bottom, which is x squared minus 4x minus 21, and factor it using the star by saying a is 1, b is negative 4, and c is negative 21. So I would need to find two numbers that would multiply together to give me negative 21, but add to give me negative 4. And so that would be negative 7 and positive 3. So I would have x minus 7 times x plus 3. But my x minus 7s on the top and the bottom would cancel. And so across the top, I would have 5 times x plus 2 over 2x times x plus 3. And so we'll leave it like that. Our excluded values would come from 2x cannot equal 0, which means x cannot equal 0. X plus 1 cannot equal 0, which means that x cannot equal negative 1. X minus 7 cannot equal 0, so x cannot equal positive 7. And x plus 3 cannot equal 0, so x cannot equal negative 3. For example 10, I need to factor the top and the bottom again, so I'm going to start with 3x squared plus 3x minus 60. On this one, I noticed that 3x squared, 3x, and negative 60 can all be divided by 3, which means that my GCF would be 3. So automatically on the top of that fraction, I'm going to have 3 times these two sets of parentheses. And so that's going to turn into x squared plus x minus 20, which makes my star a little bit easier. So now I'm looking for two numbers that are going to multiply together to give me negative 20, but add to give me 1. So that would be 4 and 5, where 4 is negative, 5 is not. So this is going to be x minus 4 times x plus 5. I also need to do x squared minus x minus 12. So a is 1, b is negative 1, and c is negative 12. So to multiply to get negative 12, but to add to get negative 1, that would need to be 3 and 4, where 4 is negative. So I would have x minus 4 times x plus 3. My x minus 4s are going to cancel, but I need to divide by x plus 5. So I'm going to, this remember is x plus 5 over 1. So I'm going to switch that and make it 1 over x plus 5. And I need to multiply. Now that puts x plus 5 on the top and the bottom, so those are going to cancel. And then I just multiply straight across. So that's going to be 3 times 1, which is going to be 3. And on the bottom, just x plus 3. So remember, to get my excluded values, I take anything that's ever been on the bottom and set it not equal to 0. So that gives me 3 excluded values. X can't be 4, it can't be negative 3, and it can't be negative 5. So now we're going to move on into adding or subtracting rational expressions. So to add or subtract rational expressions, it's just like adding and subtracting fractions. So if I had 1 over 2 plus 5 over 6, I would want my common denominators. So I would need to change this 1 over 2 into 3 over 6 so that I could add those two things together. So the first thing I want to do is get common denominators. And then I'm going to add or subtract the numerators. And I'm going to keep the denominators. And then I'll simplify if I need to. So for example 11a, you've got 3 over 8x plus 2 over 8x. So the first thing is I need to make sure they've got common denominators. So if they have common denominators, I just add the numerators. So 3 plus 2 gives me 5, and I keep the denominator. And so I don't have to simplify that at all. I'm good on that one. The only thing that x could not equal would be 0. On 11b, 7 over x plus 1 minus 5 over x plus 1. My denominators are the same, so they're going to stay x plus 1. And then I would just do 7 minus 5, which would give me 2. To get my excluded value, I take x plus 1 and set it not equal to 0. Subtract 1 from each side and get x cannot equal negative 1. On 11C, I've got 5x over x minus 3 minus x plus 2 over x minus 3. So my denominators are the same, which is good. I'm going to keep that x minus 3 on the bottom. But the problem with this one is that my numerator for the second fraction has two parts to it. So I need to make sure that I distribute that negative to both parts. So that means on the top it would be like having 5x minus x minus 2. And so when that simplifies out, it would give me 4x minus 2 on the top, and on the bottom, x minus 3. You could simplify that out just a little bit by taking out the 2 out of the top. So it would be 2 times x minus 1. 2 times 2x minus 1, excuse me. And on the bottom, x minus 3. And so my excluded value would be x minus 3 cannot equal 0. So when I add 3 to both sides, I'd find out that x cannot equal positive 3. On example 12, my denominators are not the same for part A, so I've got 5 over 3x plus 2 over 9x squared. But I want to look at my denominators and see what would make them match. So I can take this 3x and I can turn it into 9x squared. So I'm going to turn both of these, make both of these over 9x squared. To make 3x 9x squared, I would need to multiply by 3x. And if I do it to the bottom, I also do it to the top, which is going to take the top and turn it into 15x. This one was already 9x squared on the bottom, so the 2 is going to stay. And then I would just add straight across. So 15x plus 2 over 9x squared. My only excluded value would be x cannot equal 0. On B, I've got 7x squared on the bottom of the first one and 14x on the second one. So their common denominator would be if my coefficients were 14 and my variables with my exponents were x to the second. So that would make them match. All right, to make 7x to the second 14x to the second, I would need to multiply by 2. So that means I do it to the top as well. And to make 14x squared, I would need to multiply by x. So I'd multiply the top and the bottom by x. And so that would give me 3x on the top. So then I would just say 2 minus 3x over 14x squared. My denominator cannot equal 0, so x cannot equal 0. For C, 7 over 12x plus 5 over 18x squared. (12) and 18 have 36 in common. And if this one has x squared, but this one only has x, I could turn that x into an x squared. So their common factor, or their common denominator, would be 36x squared. So to take 12x and make it 36x squared, I would have had to have multiplied by 3x. And if I do it to the bottom, I also do it to the top. And if this one went from 18x squared to 36x squared, I would need to multiply the top and the bottom both by 2. So that would make 10 on the top. So then when I add them together, it would give me 21x plus 10 over 36x squared. My denominator cannot equal 0, and so that means x cannot equal 0. On example 13, I need to see if I can get these to match. But I also always want to remember that I want to factor if I can. So on the first fraction, I can't factor. On the second fraction, I can factor the bottom by taking out a 6, which will make it 6 times x minus 5. That's going to make my common denominator 6 times x minus 5. And the reason it's 6 times x minus 5 is because this one is already x minus 5. The only thing that's different about this one is it's got that extra 6 out front. So it's being multiplied by 6. So if I want to take x minus 5 and turn it into 6 times x minus 5, I have to multiply the top and the bottom both by 6. So that's going to make the top of this fraction 6. And the second one's going to stay the same. So when I add them together, I would just have 6 plus 3x over 6 times x minus 5. So my excluded value would come from x minus 5 cannot equal 0. I'd add 5 to both sides, and x cannot equal positive 5. On B, I can't factor the top or the bottom. So if I can't factor the top or the bottom, the only way I can get my common denominator is if I just take the denominators and multiply them. So if this one started out as x plus 3, but then it becomes x plus 3 times 2x minus 1, I need to take this x and multiply it by 2x minus 1. If this denominator was 2x minus 1, but I need it to be x plus 3 times 2x minus 1, I need to take the top of this and multiply it by x plus 3. So now that my denominators are the same, I would need to distribute here to get 2x squared minus x. And here I would need to do the box. So I would go over to the side and draw my box, x and 4, x and 3. And so when I put those together, it would give me x squared plus 7x plus 12. But I'm subtracting all of that. Which means that the top of that fraction is going to turn into 2x squared minus x squared minus 7x minus 12. And then I can simplify by putting my like terms together. So 2x squared minus x squared would give me 1x squared. And negative x minus 7x would give me negative 8x. And then I'd still have that minus 12. And then on the bottom, I would still have x plus 3 times 2x minus 1. To get my excluded values, I'd say x plus 3 cannot equal 0. So x cannot equal negative 3. 2x minus 1 cannot equal 0. So 2x cannot equal 1. Divide both sides by 2. X cannot equal 1 over 2. On C, I've got 5x over x plus 2 plus 1 over, and I need to factor the x squared minus 4. So to do that, using the star, a is 1, b is 0, c is negative 4. So I want to multiply to get negative 4, but add to get 0. That'd be 2 and negative 2. So that's going to turn this bottom into x plus 2 times x minus 2. Now because I want to have common denominators, this one is only lacking at x minus 2. So that would be x plus 2 times x minus 2. If that was a 5x up top, and I need to multiply this by x minus 2, then I'd multiply the top by x minus 2 as well. The second one stays like it is, because it was okay. Then I would see that because I have my common denominators, I could distribute this out. So that's going to be 5x squared minus 10x, and then I'd have my plus 1. So to get my excluded values, I'd say x plus 2 cannot equal 0. So x cannot equal negative 2. And x minus 2 cannot equal 0. So x cannot equal positive 2. Last one, so you've got 2x on the top. I need to factor x squared minus 2x minus 3 using the star. So I'm looking for two numbers that are going to multiply together to give me negative 3, but add to give me negative 2. So that'd be negative 3 and positive 1. Five will stay on the top of my second fraction. X squared plus x minus 12, I'll factor using the star. And so that would be positive 4 and negative 3. So x minus 3 times x plus 4. So I noticed that this has an x minus 3, they both do, but this one has an x plus 1 and this one has an x plus 4. That means that my greatest, or my common factor, common denominator, is going to have to be x minus 3 times x plus 1 times x plus 4. So I'm going to have all three of those pieces. So the first fraction was missing an x plus 4, so I need to multiply the top, that 2x times x plus 4. And the second fraction was missing x plus 1, so I need to take the top and multiply x plus 1. So my denominator is going to stay. My numerator is going to change a little bit because I would distribute. So that's going to be 2x squared plus 8x. Here I'm going to distribute a negative 5, so that'd be minus 5x minus 5. And then I can simplify that to 2x squared plus 3x minus 5 over x minus 3 times x plus 1 times x plus 4. My excluded values, I take my denominator, and each factor I would set not equal to 0, so x can't equal 3. X can't equal negative 1. And x can't equal negative 4.